Hello, guys, once again. In today's episode, I will teach about biophysics and biomechanics, where you usually going to learn in your first year med school. And this is going to be the uh, theoretical lecture. I'm going to do the conceptual question solving as well in the coming lecture, so stay tuned for that. And before that, I want to make sure that you subscribe to my YouTube channel, uh, and hit the like button, and if possible share with your friends. Then it will be helpful for me, as well as you at the same time you are going to learn something valuable from this lecture, so stay tuned. So I'm going to discuss about the subtopic of electrostatic and the electrodynamics in upcoming lecture. But today we are going to learn the correlation between the physics with the biology uh, for medical purposes. So I want to make sure that you watch my previous lecture on others medical subjects like anatomy. I have prepared for that and separate playlist. So in this lecture, for this lecture, we are going to discuss both physics as well as biology. So first of all, in this lecture, we are going to discuss all this. Sorry. Okay. Electrostatic and ECG of it, and the principle of electrocardiography, usually ECG, uh, to vector component using physics, and the ECG trace amplitude, parameter, mean electric axis of heart, and electric current, uh, electric properties of human body tissue. Sorry. And conductivity, resistance, um, and its effect on human body tissue, uh, using the impedance formula. And we're going to solve some views and principles of rheography. So then, sorry, effect of direct currents upon human body tissue also going to be discussed. Galvanization, to processes, to processes. I don't know how it pronounce it, but uh, just look at the matter. So energy stored in the electric field, electric power, heart by fibrillation, defibrillator, magnetic field, force of electric current in the magnetic field, force of electric charge moving in the magnetic field, energy stored in the magnetic field induction, magnetic dipole, electromagnetic induction induced EMF era, this laws of induction, Lenz's law, inductance, induced current, and RCLC circuit, electric circuit, uh, artificial pacemaker, electromagnetic waves, electromagnetic spectrum, then this wave motion of SMS, conductance of electric dielectrics, conductor, sorry, and dielectrics of electromagnetic field, high frequency alternating current, and these are all important. Electrosurgery also much important for treating the patient in case of a surgery. We all need physics knowledge, so these are going to be a valuable lecture for you as well. And thermal coagulation and welding. and many more. So, okay, electric dipole moment. And electric dipole means simply the separation between the two charges, positive and negative, with certain distance. So it is has written. So it is denoted by dipole moment p vector equal to a charge into distance of separation between two charges. That is called dipole moment. I think you have noticed in your high standard. So we are not going to be focused much. So in our high standard, when we discuss about physics, when we discuss that if there will be minus charge and positive charge, then the dipole moment can be separated to axial as well as in the equatorial position. All right, I think you are familiar with it earlier. So where L vector is distance vector from minus q charge to positive charge q. I must say negative charge q plus positive charge q. I'm an Indian student, so uh, bear with me because we most of the time consider minus plus, but in the sense that it should be negative positive charge to say in a correct way in physics. But I will try to manage it. Yes, in many molecules, even though they are electrically neutral, the electrons spend more time in the vicinity of one atom than another, which result in the separation of charge. Such molecules have a dipole moment and are called polar molecule. All right. Water is a polar molecule showing the three nuclei represented by dots and the region in which the electron can be located. The electric dipole moment P from the negative oxygen side to the positive hydrogen side of the molecule. All right. Okay. So we're going to discuss a very important terminology here. I guess I'm going to search this in internet. So first of all, this paragraph, what it states that suppose that let's assume there is an oxygen atom, quite large, isn't it? Since an oxygen atom carries negative charge and hydrogen carries I think hydrogen positive, isn't it? And for oxygen it is negative 2 minus, sorry. So in a water molecule it is a combined molecular form in this structure, uh, just like a panda shape. uh, so in a molecule, let's say this is a water molecule, even though they are electrically neutral, since the charges are of neutral, so the electrons spend more time in vicinity of one atom than another, which result in the separation of charge. Such molecules have a dipole moment and are called polar molecule. So I have just said that oxygen majorly in the nucleus it carries negative, and hydrogen it carries positive, and hydrogen it carries positive. So there is a charge separation of between the negative charge and the positive charge. So yeah, it forms a dipole moment, isn't it? So that is the point. It's that here. Which that here? Okay. The such molecule dipole moment are called polar molecule. These are called polar molecule, separated dipole molecules. Water is a polar molecule, example, and showing the three nuclei represented by dots, as I've just shown you, and the reason sorry, and the region in which the electron can be located are at the outermost, maybe the the electric dipole moment denoted by p vector points from the negative oxygen side to the positive hydrogen side of the molecule. So electric dipole moment is denoted by p vector, which indicates the point from the negative oxygen side to the positive hydrogen side of the molecule. So concept is simpler. Dipole, if you are asked to find the mm, if you are asked to find the direction of dipole moment, one should say that it is towards from negative to positive. That's the concept. So let's come to the biology part again. We all know that the systematic diagram of DNA double helix uh, is separated by each two amino acid molecule in the DNA helix, which carries certain genetic information for the hereditary, where amino acid has its own charge. It could be positive, it could be negative. So let's see. Close-up view of the helix showing how A and T, adenine and thymine, attracts each other, and guanine and cytosine attract each other through electrostatic force. And the positive negative sign indicates the certain represent net charge. Okay, positive negative sign indicates net charge, usually a fraction of electron. Due to the uneven sharing of electron, the red dot indicates the electrostatic attraction, often called as weak bond. Here you can see the red dots. All right, hydrogen bond. So hydrogen bond is a somewhat weak bond, they consider it, as compared to covalent bond and all those bonds. Okay, note that there are two weak bonds between adenine and thymine. Since you should know that one thing also, adenine and thymine are connected by the hydrogen bond of single bond, and guanine and cytosine is connected with the double bond of hydrogen. So as compared, since hydrogen is always a weak bond, but between adenine and thymine compared to guanine and cytosine, still adenine and thymine has a weaker bond attraction. All right, so that is the point what it indicates here. Okay, then, so let's come to the structure. You might be quite amazed and I must say adverse when you see this diagram. So we usually had an adverse effect of learning chemical structure uh, of any compound, but it is very important when we are going to discuss drugs in med school. So yeah, I find learning structure are much hard for me, but let's discuss one by one. So I must say this six carbon helix, and with this 1 2 3 4 5 so I must say it is the structure of adenine, simple, and this is structure of thymine, and this is structure of cytosine, and this is structure of guanine. And bone, this is the hydrogen bone. Here you can see this is the dotted line which they are connected. It's almost 0.30 300 nanometer, 0.280 nanometer. Okay, it's quite small. it is to the microscopic level. So they're connected. So I have just I think I have just informed you wrongly. uh, this one, adenine and thymine should be double bond, and guanine and cytosine must be triple bond. All right. So as you can see, there is two hydrogen bond between thymine and adenine, and cytosine and guanine, it has triple hydrogen bond. So that is the point of difference between that. And we can say that adenine thymine is lesser bond uh, attraction than guanine. Sorry, adenine and guanine must. All right, let me. Adenine and thymine, okay. And we can say that adenine and thymine has a lesser bond as compared to guanine and cytosine. So dipole moment of a selected molecule. Let's discuss the table given in the dipole moment here. For a stable molecule, the positive and negative sign indicate on which atom this charge lie. The last two entries are a part of many organic molecules and play an important role in the molecular biology. Alright? So, first thing first. Okay, this table shown here, we have to discuss the dipole strength of it. The table given in the dipole moment for several molecule, the positive negative indicates on which atom this charge lie. The last two entities are a part of many organic molecules and play an important role in the molecular biology. Last two groups often appear on the larger molecule, hence the value of the dipole moment will vary somewhat depending on the rest of the molecule. So, what it states that the positive negative sign indicates on which atom this charge lie. Okay, alright. The last two entries are a part of many organic molecules and play important role in molecular biology. Alright. The last two groups often appear on the large molecule, hence the value of dipole moment will vary somewhat depending on the rest of the molecule. So the concept is simple. This concept is just simple that. Sorry. It is important to discuss this. Metal with insulating property will polarize under the effect of electric field are dielectrics. Insulator are metal which do not allow the flow of the electric current under the influence of electric field. Thus, the electric is a kind of insulator. So let's see. Here, the below dipole moment is 6.1 into 10 to the power minus 30, and for hydrogen chloride, the dipole moment is around 3.4 into 10 to the power minus 30, and for ammonia, it is 5.0 into 10 to the power minus 30. So when I show this values, it is up to the power of 10 to the power minus 30. So with the magnitude of 6.1, 3.4, 5.0, and 3.0 and 3.0, one thing you can easily detect is that even though the magnitude of the principal values are as compared to this one is the highest, but when it's divided by 0, around 30 zeros, then even though this will be the lessest, I must say, as compared to other. So I think I'm just when you see the values of dipole moment, as you can see 6.1 into 10 to the power minus 30 and all those with same base of 10 to the power minus 30, but the magnitude here itself is almost, this one is the quite greatest among them. So it depends only on the magnitude since they are all same base, right? So after that, we're going to discuss about the dielectric concepts. This one is the most important part. So metal with insulating properties, which means no electric pass through those substances, are called insulating properties. Would polarize under effect of electric field. When every suppose let's say insulator, example insulator would be wood. So even though if it is wood, which is an insulating property, and when we provide some what can I say, the let's suppose that's a wood, even though it is insulating property, when we induce a electric field towards a wood, suppose by depolarization, it will certain amount of charge will be still collected by the insulator also, by the wood also, I mean. And after that, by doing so, when we suppose we put a magnet towards them after depolarization of the wood, it will attract or repel according to the magnitude, right? So it means that metal with insulating property which polarize under the effect of electric field are called dielectrics. Insulator are metal which do not allow the flow of electric current under the influence of the electric field. Thus, dielectric is a kind of insulator. You probably heard of dielectric before. Suppose this is the two capacitor between them. There is a dielectric which doesn't allow the flow of electric field. Those substances are called dielectric field. So, It the cell dielectric kinase insulator. So vacuum has a almost dielectric constant of -1. Air has a almost a dielectric value of 1.00054, and kerosene has 1.8. Teflon has 2.1. Paraffin has 2.2. Benzene has 2.28, and polystyrene has 2.6. And vinyl plastic has almost 2.4, and paper has almost 3.7. Quartz is the smallest charged particle. It has almost a dielectric constant of 4.8. But when we consider quartz, electron, neutron, proton towards any capacitor, then it will attract according to the preference charge. Whether it is positive or negative, it will attract or repel. Okay, oil has a dielectric constant 4. Glass, Pyrex has 5. Rubber, neoprene has 6.7. Polypropylene has 6.8. Mica has 7. Methyl alcohol has 33.6. Water has 80. Strontium titrate has 600. So that's not the important values of it.